Hello and welcome to CENOS training course Lesson 1, starting with templates. As CENOS is a fairly new simulation software for you, it is best to start with something simple to get a good grasp on the general workflow. In this video, we will take a look at how to use templates to set up a very simple scanning hardening simulation of a stepped shaft. First, we need to select our geometry creation approach, templates. As we do this, we are automatically redirected to the place where we can create the geometry of our system. In templates, geometry is created automatically, so you only need to select the necessary shape and enter the geometrical parameters. As you can see, there is an already predefined geometry for us, so all we need to do is change it. Stepped shaft is already chosen, so we just change the geometrical parameters. Our shaft geometry is done. If at any point you get confused by these properties, you can just scroll down and take a look at the drawing below, where every parameter for every shape is explained. In the same way, we need to define the inductor. Switch to the Inductor Definition tab, make sure that the correct inductor shape is selected, and enter the geometrical parameters. Notice that right now the inductor is located in the middle of our shaft. As this is a scanning application, we want the workpiece to be outside of the inductor at first, so that we could scan harden our shaft. To do this, we need to adjust the coil center offset. Once this is done, you can take a look at your geometry here in the preview screen to see how it looks. If everything is okay, click Go to Physics to switch to the next stage of the setup. After our geometry is done, we need to define the physics of our system. Right now we are at the simulation control, where we define the so-called global parameters. Part of the physics setup is colored in gray. That means that these parts are already predefined for you, so you need to focus only on the important definitions. In the simulation control, generally we need to define the frequency of our power supply and the total process time. As we have a scanning application, we also need to set a constant time step, so disable the adaptive time step and enter the calculation time step value. Enable dynamic geometry variables and define the velocity with which the coil will scan our shaft. Notice that velocity is defined with a minus sign, so that the inductor would move towards the workpiece, not away from it. To make our simulation run faster, change the computation algorithm to fast. Once this is done, switch to the Workpiece tab to define our billet. Here we need to define two things, the material of our billet and the thermal losses of it. As you see, by default, low-carbon steel with constant material properties has been chosen. As we want the material to have complete nonlinear properties, we simply close the default material and select the one we need, low-carbon steel IC1020, but fully defined. When we scroll down, we can see the thermal loss definitions. CENOS takes into account both convection and radiation losses. In this case, we don't have a cooling ring following the inductor, so we can leave the default values applied to our process. Now we need to define our inductor, so we switch to the Inductor tab. The only thing here to define is the current applied to the inductor. You can use current control, or you can input voltage as a value as well. For this case, let's go with the current control. Once we have completely defined the physics, we have finished the simulation setup. As you see, the Run button has become active as well, so just click it and run the simulation. After around 6 minutes, the simulation is finished, and the result window will open automatically. This is the end of the first lesson, where we learned how to set up our first simulation using templates. Thanks for watching!